guys, so today we're going to review Module 4. Basically everything we've done in this last month and a half, we're going to look at and break it down into a few examples of problem types. Now, you'll notice that this clearly is not a Nearpod. This is not going to be presented to you in Nearpod format because your test won't be in Nearpod format. However, you need to have paper and pencil because part of what you'll be expected to do in submitting your test answers is to also submit pictures of the work you did on paper. Because you can't just have answers, you have to show your work. So the first thing we're going to start with actually is a word problem to model the tape diagram strategy. So this problem reads, Laura saw 5 birds and 6 robins. Woo, I'm messing up already because robins are birds. Let's slow down. Laura saw 5 bluebirds and 6 robins sitting in a tree. How many birds does she see sitting in a tree? All right, now what kind of problem is this? Is this a problem we know the parts and we're looking for the whole? Or is this a problem where we know the whole and a part and we're looking for the other part? We know both parts, we're looking for the whole. So let's draw to represent that using a tape diagram. Okay, so first we're going to draw. This is where you have your paper and pencil and we're working together. Paper and pencil working together. If you don't have paper and pencil, board and marker. We're working together. So 5 bluebirds. So 1, 2, 3, 4, 5. We're going to use a capital B for the bluebirds. I know they're all birds, but we'll figure out what our all label will be. And 6 robins. 1, 2, 3, 4, 5, 6 robins. Capital R will be the label for our robins. We are trying to find out how many birds she saw in the tree. Sitting in the tree. We'll put T for tree. Question. Why did I color this one in? Yes, so I can see that I have a group of 10 and 1 more. Wait, I have 10 and 1 more? So how many birds did Laura see sitting in the tree? 11. Laura saw 11 birds sitting in the tree. What is the number sentence that matches this tape diagram? Good job. So 5 bluebirds plus 6 robins equal to 11 birds sitting in the tree. Number answer and word answer. Number answer and word answer. Good job. All right. So like I said, tape diagram to show part, whole relationship. We're just introducing them now. You will be using them some more in first grade, but definitely a lot more in second and third that I know for sure. I'm not sure about after 3rd grade, but I know 2nd and 3rd grade. These are not going anywhere. All right, so next, we're going to do an addition problem. 16 plus 15 is equal to, so what we're going to do is we're actually going to solve it twice. We're going to solve it once using the strategy where we take all the 10s and then add all the 1s, and then we're going to add it where we make a 10 and then add the remaining ones. And then you're going to tell me which one worked better. So 16 plus 15 is equal to blank. We're going to break the smaller part into smaller pieces, so that we can then add the 10s. 16 and 1 10 is equal to 26. Good. 26, which is my new larger part, plus 5 1s. 26 plus 5 1s. Well, if I take 4 of those 1s, I will create a what? Another group of 10, but I still have 1 1 left. So 2 10s plus 1 10 is 3 10s. Notice I'm still adding my 10s first. 3 10s and 1 1. 16 plus 15 is equal to 31. Now, and like I said, this is where we take the 10s, all the 10s. Now, over here, we're going to do the same problem, only this time I am going to break apart my pieces such that I get the ones I need to complete a group of 10. So looking at what we have, which part is closer to being the next group of 10? 6s, good. Is that the better choice though? Yeah. Well, I mean, you could do either one because 6 is closer, but 5 is your double. We're going to go with that rule of moving pieces so that we start with what, we go from whichever is closer. So 6 needs how many more to create a group of 10? Well, check your fingers, hold on. 6, how many are down? 1, 2, 3, 4. So 6 needs 4, leaving 11 pieces. So we're going to add 16 and 4 because we moved ones in a goal of completing a group of 10. We want to complete a group of 10. So now we have our newly completed groups of 10 plus the remaining 11 ones, which we see now we can add the 10s. 2 10s plus 1 10 equals 3 10s. And my ones place, even though there is value there, there's no change happening because this is a 0. So that is 31. 16 plus 15 is equal to 31. 2 applications of the same strategy to solve the same problem. Either one works. Either one works. And if you're just like, whoa, that's a lot of numbers, what are you supposed to do? Draw a picture. Excellent. Exactly. All right, let's do another type of problem. Let's get another problem. Ooh, this one says, there are 7 basketballs on the court. There are 8 basketballs in the bag. How many basketballs are there in all? Whoa, stop it. I didn't ask you to solve the problem. Select the tape diagram that matches the story. Listen to the story once more. There are 7 basketballs on the court. There are 8 basketballs in the bag. How many basketballs are there in all? Which of these pictures matches this story? Picture 1 or picture 2? I'm going to tell somebody your guess. Quickly, come on. Pause the video. Go tell somebody your guess. All right. You back? All right, let's see if you were right. Picture 1 matches the story. Picture 1 shows the tape diagram showing 7 on the court, 8 in the bag, with an unknown hole to show how many balls are in all. Good job. Good job. I knew you'd get it right. Okay. So now we're going to add again. We're going to add once more. This time, we're going to use number bonds again. We're going to use number bonds again. Looking at this problem, do we want to do 1s first or 10s first? You want to do 1s first? Okay, I could see that being a good idea. Because what I noticed is that in the 1s place, I have 7 and 3. Yeah, we're just going to do one of them this time. We're not doing both this time. I see 7 and 3 completing a group of 10, meaning that not only did I do 1s first, but I also got rid of all my loose ones scattered about. So 17 plus 3 more 1s now represents 2 complete groups of 10. I now am showing 2 complete groups of 10. Well, 2 complete groups of 10 plus 1 more complete group of 10 is equal to 3 groups of 10, which has the value of 30, meaning 17 plus 13 is equal to 30. And this is where you're like, okay, I know what I'm doing. I think I do, but what are we supposed to do? Draw a picture and check our work. Let's draw. 10, 11, 12, 13, 14, 15, 16, 17. 11, 12, 13. What we did was we took these ones and we grouped them with these ones. Look at my number sentence, 17 plus 3, and created a group of 10. So 10, 20, we added a third group of 10, 30. 10, 20, 30. Check, we did this correctly. This is us modeling, moving the ones, basically adding the ones first. Adding ones to complete groups of 10. We're always trying to make complete groups of 10 because as we said, 20 plus 10 is much easier than 17 plus 13, isn't it? I like 20 plus 10 better, don't you? You do? Okay, good. Okay, let's see what other kind of problem we have. Alright. The kind of problem where I can't find my clicker. Okay, here we have another word problem, meaning we're going to use the tape diagram that we learned. It says, Sean has 18 stickers. He gave some to his dad. Sean has 5 stickers left. How many stickers did Sean give to his dad? Alright, let's reread the problem. Because read, reread, draw, and label, write numbers and words. So Sean has 18 stickers. He gave some to his dad. Sean has 5 stickers left. Okay, to me, that sounds like I'm starting with the whole, which usually, typically means that we're doing what? Adding or subtracting? Subtracting, good. So 18 stickers, gave. Gave is a word that suggests that something is going on. Some, so some in the number world is either a question mark or a blank, okay? So Sean has 18 stickers. He gave some to his dad, and he now has 5 stickers left. Does this number sentence match how I was given the information? It does. This is the number sentence that matches the order in which we were given the information. But to solve the problem, to actually do the math, so this is our story sentence. This is our number sentence to match the story. Now we can have another number sentence from the same number bond for our solving of the problem. For solving the problem, I think it is more beneficial to use this number sentence. Do you agree? Okay, good. So still subtracting, we're going to draw the whole. Let's draw the whole in our tape diagram. So, let's start way over here because 18 is a decent size number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 18 is our whole. 18 is the original number of stickers that Sean has. We know that he had 5 left after giving some to his dad. We know he had 5 left after giving some to his dad. So let's break this apart, showing that he had 5 left. 5 left after he gave some to his dad. So 18 stickers is equal to having 5 left and having given some away. How many stickers did he give away? Well, I see, look how I drew this. I made smaller 5 groups within there. I see 5, 10, 11, 12, 13. So 18 minus 5 is equal to 13, which means, going back to our story sentence, 18 minus 13 is equal to 5. Sean gave 13 stickers to his dad. Sean gave 13 stickers to his dad. Notice the story number sentence, the working number sentence. Because they come from the same number bond, I could switch them out as needed. I could have also, noting the rules of this number bond, I could have also said 18 is equal to 5 plus blank, or 18 is equal to blank plus 5. Those two addition sentences are also in that same number bond. This purple here, this is what matches the story. These blue and that pink, those are other number sentences from the same number bond, which you can choose from to help you find the answer. But you do need to include, you can include these, of course, but you also need to show the number sentence that matches the story. So here we see, write 24 in 3 different ways using tens and ones. 24 in 3 different ways using tens and ones. Okay. So let's read. 24 is the same as 2 tens and 4 ones. Good. 24 is the same as 2 tens and 4 ones. So let me see this will work. Hold on. Let me try this. We're going to risk it. I hope it works. Please work. We're going to hope for it. Fingers crossed. Aha! Ha! Showing up. Yay! Alright. So 24 is the same as 2 tens and 4 ones. We're in agreement. But if I took this and I broke it down into the pieces that live inside of this group of 10, did the value, my overall value change? No, my groupings changed. Now, reading the picture, try neating these up. Reading the picture, I would say I have 1 10 and 14 ones. Can I still break this down more? I can. I can continue to break this down into the pieces that are inside, because inside every group of 10, there are, in fact, inside every group of 10, there are, in fact, 10 ones, just like your hands. Look, see? This is a group of 10. This is a group of 10. But with it loose like that, it's 10 ones, 20 ones, 21, 22, 23, 24 ones. It's pictured as all ones. So that tells us that these, like I said, breaking things apart and moving them around does not change their value. So if 24 is the same as 2 tens and 4 ones, then 24 is the same as 1 10 and 14 ones. 24 is the same as 0 tens and 24 ones. These all reside inside that final how we group the number together. Just because I grouped this together does not mean that this does not still exist. Alright, let's add one more. So the last time we moved the ones. This time let's move the tens. Nope. No, purple, come back. Ew. That hurts. Okay, this time we're going to move the tens, which means we need to break apart one of these numbers into smaller pieces. Which number do I need to break into smaller pieces? 23 or 16? 16, correct. Becomes one group of 10 and 6 ones. I am now going to add my group of 10 to the presently bigger part. So my original bigger part plus another group of 10 is equal to, well, I had 2 10s and 3 1s. I now have added another group of 10, so 2 10s plus 1 10 becomes 3 10s. My 1s, nothing happened this time. I did nothing to the 1s place, which means they stayed the same. I've added my 10s, I now need to add the 1s. So, using my larger part I made by moving the 10 over, I'm going to add the 6 1s that were left. So, 3 10s plus 0 10s is going to remain the same. 3 10s plus 6 1s, okay, we know about these pieces. We can take the bigger one first. So, 6, 7, 8, what is it? 9. 6 and 3 is 9, which means 23 plus 16 is equal to 39. 23 plus 23 plus 16 is equal to 39. What do we do to check and make sure that I did this is all in the up and up? My I's are dotted and my T's are crossed? I draw a picture. I'm going to draw a picture. So 2 10s and 3 1s, 1 10 and 4, 5, 6 1s. 10, 20, 30, adding the 10s, 31, 32, 33, 34, 35, 36, 37, 38, 39. It checks out. I did this correctly. I correctly applied the strategy of adding the 10s and then adding the 1s. Good. Ooh, that pink is hard. Alright guys, so as always, do you have any questions? Please let me know. Let me know as you're completing your review assignment today. Let me know when we meet if any questions pop up, or send me a Canvas, Dojo, text, carrier pigeon message to let me know that I need help before I take this test tomorrow. I'm still struggling to know the difference between adding the 10s and then the 1s and adding the 1s and then the 10s. I'm having a hard time seeing the connection between my pictures and my numbers. If this describes you in any way, make sure that I am aware of this and that we are working to add some extra practice in before tomorrow. Just tomorrow. So do your review assignment and then let me know if you have any questions. I'm so meaning it. I mean it, of course. But yes, let me know if you have any questions. But that's all I have for you guys. I'll see you later. And until then, bye.